All right, we are starting chapter 5. Chapter 5 is a pretty long chapter, so you only have 4 sections of it available right now, but I think there's like 12 sections total, so there's quite a few sets of notes for this chapter. But we are starting on chapter 5, and it is all about lines. So this says, list ways that we found. List ways last chapter that we would graph a linear equation, and how did we know when an equation was linear? So the first thing, let's talk about the second question first. So how did we know when an equation was linear? Those were our 3 questions. So we talked about if x and y, and we had 3 questions we had to say no to in order to know if that it was a line. So our x and y being raised to a power, on the bottom of any fraction, or being multiplied together. Those were our questions that if you said yes to any of those, then it was not a line. But if you said no, 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 then it was a line. Okay, so that's how we knew if something was linear. So all of the equations that we're dealing with in this chapter are going to not have any of those things. We're not going to have any exponents. We're not going to have our variables at the bottom of fractions, and our x's and our y's are always going to be separate. They're not going to be multiplied together. So none of those things will be happening because they will all be lines. Ways that we graphed lines last chapter, we used x and y intercepts. So if you don't remember what that means, that's when you plugged 0 in for x and got a number, and then you plugged 0 in for y and got a number, and you had those 2 points that were on the axis, and then you could connect them from there and make your line. Okay. And then we also made XY tables. So we would just plug numbers in for x, find the y, and plot the points. Okay, those are the 2 ways that we used to graph a line last chapter. This chapter we're going to learn lots of other ways to deal with linear equations. So those are the ways we've already done, and we're going to learn a lot more this chapter. We're going to start by learning about slope. Okay. I believe you already started talking about this in science a little bit, so hopefully, and I think you did it last year, so I really hope that a lot of this is review, but we just have to make sure we're really good and we know what we're talking about and go a little bit deeper and a little bit more in depth with it. So slope is a way to describe how steep a line is, okay? Whether it is steep going up or steep coming down, the slope is still just how steep it is, okay? The direction we'll get to later, but how steep is that line, that's what your slope is going to tell you. So you are going to determine how steep it is by rise over run. So the ratio, comparison of numbers, between how high a line is versus how far wide it is side to side between 2 points is going to be what we focus on, okay? So if we're looking at this, my 2 points would be here and here, and I need to compare ratio, fraction, how tall this point is in comparison to the other, and how far apart they are side to side. Okay, so I'm comparing those 2 points. If I would take this line and move this point up, okay, if I would make that rise higher, I'm making my line steeper, okay? I didn't move it over at all. I just took that point and moved it up, and it made that line steeper, so that gave me a higher slope because my rise, the top number of my comparison would be more. Okay, I'm going to have a bigger rise this time, so my slope is going to be steeper, okay? So just understand that that's what we're doing. We're comparing the position of 2 points and how tall they are versus how far side to side they are. So the greater the absolute value of the slope, the steeper the line. Remember, absolute value is the distance from 0. So absolute value is basically a way of saying that the positive part of the slope. So if I have a slope of negative 3 over 1, or a slope of a positive 1 over 3, okay? If we are just simply talking about steepness, this line with the negative 3 over 1 would be steeper because the absolute value is 3 over 1, positive. So the rise is 3 versus only going over 1. So that's going to be a lot steeper than going up 1 and over 3. Okay? So even if it's negative, we're talking about the absolute value of the slope. So this particular line, if we want to know the slope of it, and I can look between these 2 points, I'm going to count the rise. 1, 2, 3, 4. I went up 4, up is positive. Then I'm going to count the run. 1, 2, 3, 4, 5. I also moved right. So my rise from the point I decided to start at, I went up, that's positive, and I went right, that's positive. So both of the numbers were positive, so my slope is a positive 4 over a positive 5, okay? If I wanted to start at the other point, I could have done that, absolutely. I could start right here, and my rise, in that case, I would have to move down, 1, 2, 3, 4. Moving down is negative, so I would make that 4 negative. And then my run would go 1, 2, 3, 4, 5 to the left, and the left is also negative. Well, 1 negative or 2 negatives give you a positive, so that slope would still be a positive 4 over 5. But if you are counting in a negative direction, so if you are counting down or you are counting left, then the number that you get from counting needs to be negative, needs to reflect the direction that you were moving in. If you're moving up or right, those are positive directions, so then that number would end up being positive. So you have to understand, you can start at any point you want, it doesn't matter, but you have to know what direction you're moving in when you're counting your rise and your run. And you have to make sure that you are doing it in that order. The vertical distance, your rise, always has to be on the top of your fraction. That's the first number you want to compare, and your run has to be on the bottom. Comparing two numbers doesn't mean anything if you're always switching the order that you're comparing them in. The whole point is to be able to compare them with other slopes. So you have to make sure we always keep it in that order. So the top number is always the vertical distance, rise, and the bottom number is your run. Okay? So it's your change in y over your change in x. Because your vertical distance is your y and your horizontal distance is your x. So this is your formula, y2 minus y1 over x2 minus x1. If you just have 2 points, so if you don't have a graph, if you have a graph, just count rise over run. Just count how many physical boxes you are apart. But if you just have 2 points, it's going to be easiest to use that formula, y2, y1, x2 minus x1. So every ordered pair has an x and a y. So I'm going to make you label this x1, y1. They're the ones just because they're the first point listed. It doesn't really matter, but once you pick an order, you have to stick with that order. The second ordered pair is x2, y2. Okay, so I labeled them. I subtract my y's on top and my x's on the bottom. So the top of my fraction, y2 minus y1, is 5 minus 4. The bottom of my fraction, x2 minus x1, is 7 minus 2. And then I simplify. 5 minus 4 is 1. 7 minus 2 is 5. So I get 1/5. Okay? And that's perfectly fine. If I would have switched the order, okay, you don't have to do this, just watch. If I would have said, I want this first point to be my 2's and the second point to be my 1's, fine. You can do that if you want. So you would do 4 minus 5 on top. And you would do 2 minus 7 on the bottom. And that would give you a -1 over a -5. And again, 2 negatives give you a positive. And you would still end up with 1/5. So I'm proving to you that it doesn't really matter which point you make your 1s and which point you make your 2s, but you have to keep that order. If I'm doing y2 minus y1 on the top, I have to do x2 minus x1 on the bottom. Okay, so you can go ahead and do 1 and 2 on your own. Okay, so label them. x1, y1, x2, y2. Subtract your y's on top, your x's on the bottom, and then find the slope. So you can pause me and do those and then come back. I'm going to do number 3 with you. So for number 3 is just a graph. So the easiest way to do it when you have a graph is to count. So I starred these points because they were at specific places on the axis. And then I can count. If I want to start the point down here, I'm going to count always rise over run. So I move up 2. So up is a positive movement, so I have a positive 2 on the top of my fraction. And then I'm going to move right 1, 2, 3, 4. Right is also a positive movement, so that's a positive number. And then 2/4 reduces to 1/2. If I would have wanted, I could have started up here and gone down 2, but down is a negative movement. And left 1, 2, 3, 4. Left is also a negative movement. And a -2 over a -4 still reduces to a positive 1/2. So if you have a graph given to you, it's going to be easier to physically count rise over run. And it doesn't matter what point you start at, just know what direction you're moving in, whether or not it's positive or negative. So that's what you're doing on the exploration. So you can pause these notes, go to the exploration. You are going to do exactly what we just did for number 3 at the graphs. You do not have to go both directions. Just pick a point to start at, count your rise, write it down, count your run, put it on the bottom, and then simplify if you need to, okay? So you're just finding the slope. And then the second part asks if the slope that you found ended up being a positive number or a negative number. And so then the goal is to be able to look at a line and know if the slope is positive or negative. Okay, so pause this, go do that quick little 4 questions, and then come back. All right, so what you should have found about your slopes is if a line is going up from left to right, it is a positive slope because you counted up and right, which are both positive movements, or you counted left or down and left, which were both negative movements, and 2 positives or 2 negatives give you a positive regardless. So a line going up from left to right is a positive slope. That's what we should have found. A negative slope is coming down from left to right because one of your movements was positive, but the other one was negative. So when you were counting, maybe you started down here and you went up, which is positive, and that's great, but then you would have had to go left, and left is negative. So 1 positive and 1 negative gives you a negative slope, okay? Or if you would have started up at the top, you would have gone down, which is negative. Okay, so that would have been your negative, and then you would have gone right, which is positive, and again, 1 negative and 1 positive still makes the entire fraction negative. Okay, so you have to pay attention what direction you're moving, but just know when you look at a line, if the slope is going down from left to right, then it is going to be a negative slope. Okay, so you have to pay close attention to that because once you're finding slopes in all these questions or you're graphing lines yourself, I'm always going to ask you to double check and make sure your line's going the direction you want it to go. If you have a positive slope and your line is going down, then you did something incorrectly. So just always be aware of what's going on and what direction your line is going to make sure we know what we're doing. Okay? What about a horizontal line? Okay, so if we just pick 2 points on this horizontal line, they're all, doesn't matter which 2 points you pick, they're all on specific points. If I want to count my rise in between these 2 points, my up and down is nothing. I don't have to move up or down at all to move between those 2 points. So my rise is 0. My run, in the case that I picked these points, is 1, 2, 3, positive 4, because I decided to move right 4. Doesn't really matter. Because even if you would have picked points right next to each other and gotten 1, or you would have moved backwards and gotten -4. It doesn't matter what your run is, what your side to side is, because 0 divided by anything is 0. All horizontal lines have a slope of 0. All horizontal lines have a slope of 0. Okay? So, because if you think about it, this is like the ground in Ohio, right? Completely flat, easy to walk on, no slope, no incline, right? No steepness to it at all. You could walk on this all day long and it would not be difficult, okay? So, horizontal lines, easy to walk on, flat land, no slope, no incline, no steepness, is a slope of 0. Vertical lines are the complete opposite, okay? If I pick 2 points on a vertical line, and I count my rise, in this case I picked points that were 3 apart, so my rise was 3. But my run this time is 0. I don't have to move left or right at all to get from point to point. If you put 3 over 0 in your calculator, it's going to tell you that there is an error, okay? I can't take 3 things and split it into 0 pieces. That's what that's asking you to do. Divide 3 into 0. If I have 3 things, I have 3 things. I can't divide it into nothing. So dividing by 0 is not something that's going to be able to work. If you have a 0 on the bottom of a fraction, your slope is what we call undefined. Okay, undefined. It is so steep that I cannot even put a numerical value to that slope. Okay? Think about it this way. Can you walk on this? If this were your road, could you walk up it? Just by yourself? No, you can't. Okay? So your horizontal line was so easy to walk on, just flat, nothing happening, slope of 0, easy peasy all day long. Your vertical line is so difficult because it's straight up and down. It's like trying to climb up a wall without any assistance. That's so steep that you can't even put a number to it, so that's undefined. So 0 on the top, slope is 0, 0 on the bottom, your slope is undefined. Oops. So vertical lines have a slope that is undefined. Okay? All right. I'm going to do the last one with you, and you're going to do the other 3. So if you want to do the other 3 right now, you can, and then come back, or just do this one with me and then go back. So remember, we're going to do, if I'm just given 2 points, I'm going to do x1, y1, x2, y2. Rise over run, y's over x's. So I'm going to subtract my y's on top, y2 minus y1. So 5 minus 5 on top over my run of 3 minus 10 on the bottom. 5 minus 5 is 0. 3 minus 10 is -7. I have a 0 in my slope, okay? When there's a 0 in the slope, it's the only time you're not writing your slope as a fraction, okay? Because when there's a 0, it's either 0 or undefined. 0 on top is a slope of 0 because that would be a horizontal line, okay? Horizontal line. Also, side note, equations of horizontal lines, if you remember when we talked about this a little bit when we did functions. Equations of horizontal lines are always y equals a number, because all horizontal lines, so a horizontal line shares the same y value all the way through. In this case, my y values were 5, so the equation of that line would have been y equals 5. Okay? Just good to always think things through and familiarize yourself with linear equations. So horizontal and vertical lines only have one variable in the equation. They're still linear, but they're the weird ones that only have one letter in them. And it's whatever letter matches. So since the y's were the variables that matched, then it's a y equals and then 5. That's just for the future to remember. Right now we're just kind of focusing on the slope. The slope was 0, so it's a horizontal line. Okay? All right. You're going to do your 5-1 worksheet and let me know what you need.